Okay, last lesson for the unit, 6.5, angles of elevation depression. The good thing about this is we're not learning a lot of new things. We're just learning some new vocabulary to put with it, but the process is still going to be the same. So the way we form our angle of depression here is by forming it with a horizontal line and the line of sight to a point below. So if I look here at our picture, angle 2 is our angle of depression. We can see here our horizontal line and our line of sight is going down, and that forms your angle of depression. In the reverse of that, angle of elevation, it's still a horizontal line, but your sight line is now looking up. So think of in terms of that picture, the plane is looking down at the tower, forming your angle of depression, and the tower is looking up at the plane, which forms your angle of elevation. Now, the nice thing about this is these two lines here that I just highlighted, these dotted lines, are parallel. And because those lines are parallel, we know that angle 1 and angle 2 in this picture are going to be congruent because they are alternate interior angles. And when we have those alternate interior angles, we learned that when the lines are parallel, the angles are congruent. So if you have the angle of elevation or you have the angle of depression, it doesn't matter. Both of those angles will always be the same because of your parallel lines. So let's look at the first example. So remember we said that no matter what, we're always going to start with a right triangle. So let's go ahead and draw that right triangle, and we'll add to it. So we know that the Seattle Space Needle casts a 67-meter shadow. Well, we know shadows are always found here on the ground. And so we know that that is 67. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is a Space Needle? Well, if it's asking for how tall something is, we know that we are looking for the height, so we need to find this side here. If you want to add that the Space Needle is represented by the vertical side, go ahead and do that. Now let's talk about this angle of elevation. Remember, angle of elevation is the horizontal line and then looking up. So right there is your angle of elevation. So this is 70 degrees. And now we have our sides ready to go. So we know that we're going to go from the perspective of the 70 degrees. So label your sides. X would be your O. It's opposite. 67 is our A. So O and A means we're going to use tangent. And if we're finding a side, we're going to set up our equation. Tangent of 70 degrees equals O over A, so X over 67. We know that to get rid of the 67, we're going to have to multiply by 67 on both sides. So in your calculator, you would type 67 times the tangent of 70 degrees, and that's going to equal our X. And if you plug that into your calculator, you should get 184.081, but it's asking us to round to the nearest meter, so we know that it would be 184 meters. And that would be your answer. So again, nothing really changed except for them telling you that you had an angle of elevation, and you use that to label and solve for your missing side. So let's look at the next one. We have an ice climber, and again, we can keep reading. We're going to pause for just a second and go ahead and set up our picture. We know it's going to be a right triangle. So this ice climber stands at the edge of a crevice that is 115 feet wide. So that's something to think about, wide, width. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. They want to know how deep the crevice is at this point. Let's go with some words that we understand here. We know that wide is width, that's our horizontal distance. So we know the 115 would go here. We know it's asking for how deep it is. So deep is a vertical distance, so we're looking for this side. And so if we think about this in terms of what it's saying with the ice climber, we know that a crevice is like a deep valley, something like that. And so we have our ice climber standing here at the edge looking down because it's that angle of depression. But remember, angle of depression is formed with the sight line and looking down. So your angle of depression is really right here outside of the triangle. But because we said at the very beginning that we have those parallel lines here and here, your angle of elevation, angle of depression would always be the same. So if your angle of depression is 52 degrees, then the angle inside the triangle, where the angle of elevation would be, would also be 52 degrees. So now you have everything you need to label this. So if we're standing here at the 52, we would label, and we would say that x is opposite of the 52, 115 is adjacent, and so O and A means that we're going to use tangent. So we would say the tangent of 52, our angle, equals, our ratio is O over A, so x over 115. 115 is on the bottom. To cancel it out, we would multiply both sides by 115. So in the calculator, we would say 115 times the tangent of 52. Make sure again that your calculator is in degree mode and it wants to know to the nearest foot. And so if you plug that in to the nearest foot, you would get 147 feet. Okay, last one here. Let's go ahead and set up our picture before we even look at what we have. Okay. All right, we got a pilot of a traffic helicopter sights an accident at an angle of depression of 18 degrees. Well, we know that if your helicopter is in the sky and it's spotting an accident, then it's going to be in the air. So we know our helicopter will be up here. And so its altitude is 1,560 feet. Well, altitude is height, so we know that would go right here. What is the horizontal distance from the helicopter to the accident? So horizontal is the bottom part, so we're looking for that. It told us that because it's the helicopter looking down, remember, angle of depression is the horizontal distance looking down, creating that angle here. And if that angle is 18 degrees, remember our lines are parallel, so we also know our angle of elevation would also be 18 degrees there. And so now we're ready to go. We have our 18, we're going to label, 1560 is opposite, x is adjacent, O and A, tangent again. A lot of times when you're doing angle of elevation depression, you will use tangent. Not every time, but a lot of the time you will. So tangent of 18 equals our ratio, O over A, 1560 over x. X is in the denominator, so we know that we're going to have to divide, so we end up switching the x and the tangent of 18, so we would say 1560 divided by tangent of 18, and we would plug that into our calculator. And it's not specific on what they want us to round, so we'll go to our standard of rounding to the nearest thousandth, and so we would say 4,801.186 feet. I do want you to label because these are real world problems with your word problems, and so go ahead and label with either feet or inches, meters, whatever it's working with. And so if you look here, those are your 3 examples. Set it up just like we've been doing the last few days. Just pay attention to, is it angle of elevation or angle of depression? It'll go in that same spot every single time. If it's depression, it starts outside the triangle, and then it ends up at the bottom because those angles are congruent.